In section 3.6, we continue working with mixed numerals, and here we learn how to multiply and how to divide using mixed numerals, and then we do some application problems. Now, the way we multiply mixed numerals is we first convert to fraction notation and then multiply, and then we convert the answer to a mixed numeral if that is appropriate. So let's look at an example. It is a guided solution. So here we have 2 times 6 and 2/5. First step is we convert 2 to fractions, that's 2 divided by 1. And the second step is we convert 6 and 2/5 into a fraction. Remember how that goes? We multiply 6 times 5, and that's 30, plus 2 is 32, so that's 32/5. And now, this is a problem that simply reduces to multiply into fractions. So 2 times 32 is 64. It's 64/5. And when we convert 64/5 into a mixed numeral, dividing 5 into 64, that's equal to 12 and 4/5. Again, this is a step that you should be able to take yourself, and if that's not quite clear to you how that's done, please refer to the previous section where we learned how to do this. The next few exercises are very similar. We look at number 1, so 6 times 3 1/3. So first we convert 6 into a fraction, that's 6 divided by 1, and then 3 1/3, that's 3 times 3 is 9, and 9 plus 1 is 10, so that's equal to 10/3. And so now we multiply 6 times 10 is 60, and 1 times 3 is 3, so that's 60/3. And that would be the same as 3 times 20 divided by 3 times 1. And that reduces to 20 divided by 1, or simply 20. So that's the answer for number 1, 20. Exercise number 2 is very similar. So here we convert 2 1/2 to a fraction. So 2 times, well, let me write down, 2 1/2 times 3/4 equals, so we convert 2 1/2 to a fraction. 2 times 2 is 4, plus 1 is 5, so that's 5/2 times 3/4. So it's 5 times 3 is 15, and 2 times 4 is 8. And as a mixed numeral, we divide 8 into 15, would be 1 7/8. So here the answer is 1 7/8. And to do number 4, we convert 3 1/3 into a fraction. So 3 times 3 is 9, plus 1 is 10. So 10/3 times, and 2 1/2 we convert into a fraction. 2 times 2 is 4, plus 1 is 5. That'd be 5/2. And 10 times 5 is 50. Divided by 3 times 2 is 6, and we can reduce that to, but my idea is 2 times 25 divided by 2 times 3. The 2's cancel, so that's equal to 25 divided by 3. And when we convert this now to a mixed numeral, we divide 3 into 25, which is 8 1/3. So 25 divided by 3 is equal to 8 1/3. So this is the answer for number 4, 8 1/3. And as always, I recommend you grab a piece of paper and a pen or a pencil and work it out for yourself. When we're dividing mixed numerals, we use a similar approach. To divide using mixed numerals, first write fraction notation and divide. We know how to divide fractions. And then convert the answer to mixed numeral if appropriate. So when we follow the rule here, how to divide using mixed numerals, we convert 84 to a fraction, so it's 84 divided by 1. Divided by, now we convert this to a fraction, the fraction notation. 5 times 4 is 20, plus 1 is 21/4, 21 divided by 4. And we know how to divide a fraction by fraction. We multiply the first fraction by the reciprocal of the second fraction. So this then is 84 divided by 1 times 4 divided by 21. So 84 times 4 is 336 divided by 21, and 336 divided by 21 is equal to 16. This then is the answer to this particular problem, so 16. The next exercise is very similar. 26 divided by 3.5. In other words, we convert 26 to a fraction. 26 divided by 1 divided by, and this becomes a fraction. 3 times 2 is 6 plus 1 is 7/2. And so now we multiply by the reciprocal of the second fraction. That's 26 divided by 1 times 2 divided by 7. And 26 times 2 is 52. And 1 times 7 is 7. And when we convert this to mixed numerals, 7 divided into 52 is 7 3/7. This is the answer to this exercise here, 7 3/7. In the next exercise, which is a guided solution, we're dividing 2 1/4 by 1 1/5. By converting 2 1/4 to a fraction, we get 2 times 4 is 8, plus 1 is 9/4. And 1 1/5 is 1 times 5 is 5, plus 1 is 6. That's 6/5. So we divide a fraction by multiplying by the reciprocal of the second fraction. That's 9/4 times 5/6. And when we factor 9, we get 3 times 3 times the 5 here. In the denominator, we get 2 times 2. 2 times 2 is 4, and 6 is 2 times 3. Continuing then, we can cancel 1 3 against the 3. Or we write as 3 divided by 3, either way. And then we have 3 times 5 in the numerator, and in the denominator we have 2 times 2 times 2, which is 8. 3 times 5 is 15, and 2 times 2 times 2 is 8. And when we convert 15/8 into a mixed numeral, it's 1 7/8. So as you begin to see, we are now putting a lot of the things together we studied before. And so I hope you feel comfortable with the process and the individual steps as well. Number 8 is very similar as like the example we just did. We convert 1 3/4 to a fraction. 1 times 4 is 4 plus 3 is 7, 7/4, divided by, and 2 1/2 is 2 times 2 is 4 plus 1 is 5/2, so 5 divided by 2. So that is equal to 7/4 times the reciprocal of the second fraction, or 2/5. So we have 2 times 7 divided by 2 times 2 times 5, or 2 divided by 2 times 7 divided by 2 times 5, and the 2 against the 2 is a 1, and so we only have 7 divided by 10. 2 times 5 is 10, which is our final answer. Number 9 is an application problem, and it says Kyle's pickup truck travels on an interstate highway at 65 miles per hour for 3.5 hours. How far does it travel? When you think about it, these 65 miles an hour for 3.5 hours, that means multiplication. So in a more general way, you may want to remember this formula, that distance equals the rate of travel times time. That's a good formula to keep in mind. We'll be using that in the future again. So let's just d equal the distance it traveled, distance Kyle's pickup traveled, Kyle's pickup traveled, and then r is the speed, and t is the time. So we translate this and say, okay, the distance traveled equals r times t. In other words, the speed is 65 miles per hour times the time, and the time is 3.5 hours. Now we solve this problem like we have learned in the section here, multiplying mixed numerals. So d is equal to 65 times 3.5, or 65 divided by 1, and 3.5 would be 3 times 2 is 6 plus 1 is 7/2. And so 7 times 65 is 455 divided by 2. We convert this into mixed numeral by dividing 2 into 455, and that is 227 1/2. So we check our answer, and we check it by repeat the calculations. Repeat calculations. Again, to have clarity, we multiply the speed, 65 miles per hour, times the time, and that's 65 times 3.5, and so the numbers all checks. 3.5 is 7/2, multiplications check. So that is the distance traveled. So now we state our answer. Coyotes pickup truck traveled 227.5 miles. Again, the unit of measure, miles, is critically important when you specify an answer. Simply because there are other measures, units of measure like kilometers and others. So anyway, be explicit, and that would be stating our answer. Number 10, Holly's minivan traveled 302 miles on 15 1/10 gallons of gas. How many miles per gallon did it get? The word per gallon indicates division. So let's say that the M is the miles per gallon. And so miles per gallon means we divide the miles by the gallons. So in other words, miles traveled divided by the number of gallons of gas. So I changed it to MPG. So MPG is a miles per gallon, and that's equal to miles traveled, the number by the number of gallons of gas used. So we translate this and say, so MPG, so how many miles did the van travel? Well, miles traveled is 302 divided by number of gallons of gas. I'm just going to make it, yeah, number of gallons. Of gas, and that's 15 1/10. The next step is to solve the this problem here. We solve it. So MPG equals 302 divided by 15 1/10. So that's equal to 302 divided by 1 divided by 15 1/10 is 10 times 50 is 150, plus 1 is 151 divided by 10. We divide a fraction by a fraction by dividing the first fraction by the reciprocal of the second fraction, 10 divided by 151. We rewrite the fraction, the numerator and denominator now as factors, and 302 we write as 151 times 2. We write 10 as 2 times 5. In the denominator, we have 151 times 1. So 151 divided by 151 is 1. That leaves us a 2 times 2 times 5, which is 20 divided by 1, or simply 20. So we check our answer by repeating the calculations, So we want to be careful about the factoring and the subsequent cancelling. So 302 divided by 1, that works out. 151 divided by 10, multiplied by the reciprocal. 302 is 2 times 151, and 10 is 2 times 5. In the denominator, we have 151 times 1. So this is equal to 1. That leaves us with 2 times 2 times 5, which is 20, and then 1 in the denominator, and that's equal to 20. So we state that Holly's minivan got 20 miles per gallon. And as you can see, the units of measure become more and more important when we have, problems to solve like this. To write down 20, that might indicate you don't really know exactly what that represents, but it represents 20 miles per gallon. So always think about the number and what it represents. In this case, 20 miles per gallon. In the next exercise, there's a koi pond. So Colleen designed a koi fish pond for her backyard. Using the dimensions shown in the diagram, determine the area of Colleen's backyard remaining after the pond was completed. So when we look at the diagram, we see there's a yard here, the backyard, 40 yards by 27.5 yards. Inside is the design for the koi pond. And that has dimensions 15 by 10 1/3 yards. So let's familiarize ourselves with it. So I redrew the situation here with simply straight lines. And so we're dealing with two areas. One is a large area, the backyard, 40 yards by 27.5 yards. So that's a larger area. So A is the total yard area. And inside we have the design for the koi pond. That's a smaller area. So A would be the area of the koi pond. And then the question, determine the area of Colleen's backyard remaining after the pond was completed. That would be the area I'm going to shade in here for you. So it would be the remaining area, right? It's a large area minus a small area. So let's say R is the remaining area. Remaining area. After the pond was completed. So when we translate this now into a statement, we can say that the remaining area is equal to the total yard area, the A minus the area of the pond, or for the pond. So in other words, R, the remaining area, is equal to, now the area of the backyard is 40 yards by 27.5 yards. So 40 times 27.5, that would be the total area of the area of the yard, minus the small area, and that's the smaller rectangle here, and that is 15 times 10 1/3. There's a minus sign here. So that's a large area, that's a small area. We subtract one from the other, and that gives us the shaded area, the remaining area after the pond has been completed. So now let's solve this problem. So the multiplication of 40 times 27.5 is 40 divided by 1, and we convert this to a fraction. 27 times 2 is 54, plus 1 is 55. 55 halves, or 55 divided by 2, minus the other area, that's 15 divided by 1, 15 divided by 1, times 10 1/3, we convert that to a fraction. 10 times 3 is 30, plus 1 is 31/3. Now we're going to write each term as each factor as a, in this prime factorization. So 40 in this prime factorization is 2 times 2 times 2 times 5, times 55 is 5 times 11, divided by 2 times 1. 1 times 2, 2 times 1, minus, now 15 we factor as 3 times 5, and 31 is a prime number, so we cannot factor that, divided by 3, or 1 times 3. And here we have 2 divided by 2, or equal to 1. And then remaining is 2 times 2, 2 times 2 times 5 times 5 times 11, divided by 1, minus, and here we have 3 divided by 3, 3 divided by 3 times 5 times 31, divided by 1. And we know that 2 divided by 2 is 1. In other words, we only have 2 times 2 times 5 times 5 times 11. So that's 100 times 11 is 111, 1,100. And 1,100 divided by 1 is 1,100. Minus, and 3 divided by 3 is 1, so we only have 5 times 31. And 5 times 31 is 155. And when we subtract 155 from 1,100, we get 945. So then we check the numbers, check our calculations, again by looking at the numbers. 40 divided by 1, that's correct. 55 divided by 2, correct. 15 divided by 1, and that's 31 divided by 3. The factorizations check. 2 divided by 2 leaves a 2 times 2 times 5 times 5 times 11. And here for the second term, we have 3 divided by 3, 5 times 31 divided by 1. And so 2 times 2 is 4, and 5 times 5 is 25, that's 100. 100 times 11 is 1100. minus 5 times 31, or 155, so 945. So we checked that. So we recalculated. Repeating calculations. All checks. And now we state our answer. And that is that the area remaining after a point was completed. The area of the backyard so here we state our answer. The area of the backyard remaining after the pond was completed is 945 square yards. Again, it's important to have clarity about what that number represents. In this case, it's square yard. This is the end of section 3.6.